Okay, just checking. Can everyone hear me, and can you see my screen all right? Hello?
We can hear you and see your screen.
Okay, good. Thank you. Yeah. Right. I think what we are going to do, I'm going to present here is maybe, you might call it a different kind of fall, in the sense that, it's a high level implemented on all these high level languages. As you can see in the second paragraph there, we have implemented it on JavaScript, Python, PHP, and so on. And I think I'll just jump straight into the code, and because I'm sure all of us here are like veteran or experts, so I can skip the you can go through the text yourself, and maybe the first part of the slides. Right now, okay, I think what we might have sort of the fourth community might have sort of needs is that we actually forgot to give a name to what we're doing, right? Now, what I'm trying to show here in this slide, right, is this the shunting yard algorithm, which was conceived by Dijkstra himself, right? That turns the infix notation to the reverse Polish notation. And what I think Forth has been doing is actually the inverse process. But not having coined the term inverse shunting yard algorithm, I think make us lose out from the academic circle, because I think the academic people like to have a name for everything. And so in fact I coined this term, and I'm not sure this term has been coined by other people, because I haven't really published a paper on this thing except for just putting it on a YouTube. So I hope someone would collaborate and popularize this term. So anyway, so you got the idea here right now. So I think I'll just jump straight into the code itself, instead of just going through this slide, which I'm sure everyone can has already know, right? Okay, so now what I'm going to show here is that this is an implementation of what we do. Okay, we call it phoscript. Yeah, just want to pick a name which I hope popular with the younger programmers nowadays, right? They have this JavaScript whatever script, so I call it phoscript for the one of the reason being that phos is of course being light in Greek, and also me being Chinese, right? We find it difficult to pronounce fourth anyway. So there's quite often we omit the R sound. So anyway, so that's something maybe not quite relevant. Now, so what happened is that, yeah, it's really simple. As I described the idea in literally is all written in the second paragraph of this this PDF. That is, we just simply take a space delimited string, okay, and split it. So as you can see, it is actually done inside this first line here, or the second line here, 8852. Now, you might notice that this explode is actually a PHP function. So I originally have written this phoscript in the PHP. So, but when I ported it over to JavaScript, so I try to save time, right? To not to change too many of the functions. So I just rename the function to do the same. So split the string into a token, all right, and later is actually just calling. Just a minute, okay. Right. Okay. I think I'll need to do this. Right. Okay. Right. Right. It's better here. All right. Now, so basically, this function looks very long, but what it does is really simple. Just split the string into a token and go through lots of checking and then call eval, right? Somewhere down here. Yeah. Okay. So eval is, of course, as you may know, is a standard kind of constructs. Yeah. Discouraged, to be used by amateur because, it actually breaks. I mean, according to, all these experts, it will break the programming language, but I don't think it does. So it's just a loop of, taking the, what do you call it, this a string and then split into a token and then call the functions. And as you can see, there are, so all this, like whatever prefix here, this, like, for example, swap, right, is implemented in JavaScript as such. All right. So that's all it is. That's the whole idea. Now, the reason I started doing this is because when I try to learn forth myself, I thought that, instead of going through all the forth vocabulary, I might just, skip the main vocab and implemented the core function, so that then I can actually use the library, I mean the API or the functions of just JavaScript directly. So what I'm going to do next is that I'm going to demo a website, or in fact, I shall call it a full stack framework, as in it actually consists of the front end and back end, where the front end is written in JavaScript and the back end is written in PHP. Now, the interesting part is that both the front end and back end are interfaced with Phoscript. So, for example, okay, as you can see here, now this is the initialize routine here. So it consists of a series of, right, for example, this one. Okay, these are actually a series of column definitions, of course, implemented in JavaScript. I mean, the low level is actually JavaScript. And it actually, all this thing does is RSA encryption. Okay, so I'm going to show a little bit of this. Okay, so for example, we can actually do login here. Okay, okay, this is to generate the key, public key and the private key, and then do authentication. Right, and so basically, what this thing does is that it sends the the public key from the front end to the back end, and then the back end, the PHP code actually generate a random byte string and encrypt the secret phrase. Okay, this is called a secret phrase with the public key, and send it back to the front end. So now the front end actually has the private key. Okay, so it will be able to decode the secret phrase and send it back to the back end, so to authenticate itself. So with this, we actually implemented a system based on public key cryptography that does not need centralized authentication. So if I can just show you something at the, that, okay, you can see that these are like the stack. Okay, and in fact, when we do this, so you see that there's the stack item here. There are 9 items here. Okay, the private key and the public key and so on. So it's the familiar. I'm sure. I mean, everyone in doing forth familiar with this, but of course, this is a web programming. Now, it's interesting that I think Brad Nelson just now talked about web-based forth. I think these are actually taking 2 different approach. I would say the approach I'm taking is actually top-down, and what Brad did was actually bottom-up. Okay, So I think that would be a sort of a good introduction to what we have done with this phoscript, all right? And for the next part, I would like to invite Demitri to present a little bit of his work, because I think it's really nice that this concept of phoscript, where we actually do the minimal of phos and can be ported to hardware programming. So Demitri, would you like to take over and share screen? Thank you.
Yeah, thank you very much. I think I need you to stop sharing first, and then I'll be able to share. So thank you, everyone. I will show my face briefly, but I will switch off my camera afterwards to preserve my bandwidth. So hello, everybody. And I'll be talking about what I've used Phoscript for. So hopefully you can see my presentation, and I will start. So Liang, just let me know if you can see the slides.
Yep, the slide is all right. Yeah, we can
Great.
see the slide. We can hear you. Okay, go on, please. Thank you.
Great. So Liang mentioned before about the inverse shunting yard algorithm. And I saw his work a few years ago, actually, in 2020, he did a presentation on this. And he claims that the Phoscript could interface with any known programming language. And I challenged that. So I thought, okay, fair enough. What do I use? What do I personally use? And since I work as a design engineer in a company, I actually use hardware description languages, and in particular using System Verilog, which is kind of like a superset of Verilog. So it's like C++ to C, but these are languages of the hardware design world, you could say. Right, so what are the challenges? Well, one thing that you have to keep in mind is that when you write something in a hardware description language, like Verilog or System Verilog, I might use them interchangeably in this presentation for the sake of simplicity. What you're describing is a piece of hardware, something that is static. You're not describing a program, even though some of the things you write may look like a program. So you could say that the code you write is actually declarative rather than imperative, for example. And some of the two most popular languages for this are Verilog and VHDL. I chose to use the former since it's actually been a while since I used VHDL. Of course, you also have simulation, but a simulation is kind of different because simulation does not change the design, it just kind of runs it. So you've already described your design, you run it. In the area I work in, a lot of this stuff is written in Tcl. I don't know if you've heard of Tcl before, it's another scripting language. But this is, again, a different field really, more to do with simulation. And also you'll have some non-synthesizable Verilog or VHDL. So this is, you do have things in Verilog that actually execute more than describe hardware, but the difference with that is you can never turn those things into hardware, they'll only ever be software. So how do we get Phoscript to interface with hardware? Well, this is different because with the traditional Phoscript, we normally use it at runtime. Okay, so you have like a complex running C or C++ program or JavaScript, as Liang showed before, and that program is running and you're just interacting with that program. On the stack, you put your calculations, put all your data that you're calculating on the stack, and you have words that process that and do whatever. And the next thing is that you implement it in the target language. So if you want it to work with JavaScript, you write the implementation in JavaScript, which seems very logical, but I'll explain why that's something of interest next. One of the issues with this potentially is people might criticize that the interpreter will be slow because phoscript is interpreted and is probably going to talk to a language that is also interpreted, so it gets slowed down. And for those who are seeking performance, they might notice that there's a bit of a performance hit. Now, my approach, which works well for the problem I was trying to solve, is to use phoscript for code generation. So this is another way of using the inverse shunting yard algorithm. And what we basically do is we write something in a kind of forth syntax, but instead of putting data on the stack that gets used in calculations, we actually put fragments of code. So as you're writing this forth, we're building up the program on the stack. Now, one thing about this is it does not have to be implemented in the target language, because my forth or phoscript to system Verilog implementation is actually written in Python. For the record, I hate Python. I really hate Python, but I happen to be very knowledgeable in Python as well, and it was quick to write, so I used it. Now, the difference here is you can compile or synthesize the results. So you could say there's no loss of performance compared to using that language. So say, for example, it's C you're working with, and you generate a C program. Well, you compile that C program and you now have the speed of C. You don't have the slowness, you could say, of your interpreter. Of course, the disadvantage is you don't get that interactivity with the running program. But this was appropriate for hardware design, where you don't really interactively configure hardware as you go along. Oh, sorry. And one more point is that a good thing about this approach as well is that you can possibly simulate the intermediate language. So you might be able to write a simulator. So here's a small example. If I had a little bit more time, I would have done a live demo, but I will just go through this quickly. So what we're doing here, we create a number of definitions. One here is to count up a register. So we create a register that counts up. We can create a register that does inversion, and we can kind of put those together along with a few other words to create a pulse width modulation module. So what this is useful, Don likes this block, is for driving motors, for example, because you can turn a signal on maybe 10% of the time and off 90%, and you can change the percentage that is on to kind of effectively produce a different output voltage. And as you can see, even though I've written forth up here, we get Verilog generated down below, which can actually be synthesized. So what would I do next? The further work to do is to implement a reasonable subset of Verilog. I've only done a little bit of a start on this. We need to do more examples, perhaps a fully synthesized module, and work towards something substantial like a processor, for example, the J1. That would show that you can actually use this homotronics for hardware design. Perhaps in the future, could also write a small simulator for this language too, which would be helpful when you're producing designs to see if they work. And finally, as I said before, I hate Python. So I want to see if I can move away from Python, maybe implement this in Forth instead, so I don't have to touch it again. So that's all I'm presenting, and I will hand back to Liang.
Hi, all right, yeah. Kevin, just checking, how many more minutes do we have? I think we started late, so just wondering. Kevin?
Can you hear me now?
Kevin? Yeah.
Okay, so let's do the simple calculation, and say you've got 15 more minutes. Does that suit you?
Oh yeah, okay, then good then. Yeah, I thought that we don't have much time. Okay, that's good. Right. So 15 more minutes. All right. So I'll continue with this some of this presentation. Right. Just a minute. Okay. So what I'm going to show next is right. Okay. Now there are some examples on YouTube which I won't bother to go through them because you know, but I'll just mention that quickly. So this video I have shared on YouTube already. So you can see that we have done this, you know, something every web programmer is doing. These the AJAX, meaning to send instructions from the front end to the back end. All right, and then the simple one cell HTML table. Okay, maybe I'll just open this video. Just a minute, let me see. Right, I'll just freeze the screen, you know, although I wouldn't play the video because they will be quite long. Right. Yeah, some of this video is actually Jigstra himself talking while he's still alive. I think I took this clip from the Dutch television, some of very rare stuff. Yeah. Yeah, so this is a demo screen for this the AJAX, yeah. Yeah, if you are not familiar with web programming, so this you can take this as an intro. So I thought that yeah, you can see that, you know, we enter the, of course this is called the browser console where you can actually key in commands. So this is the front end where the web browser sits, and then when you do send, it actually communicates with the back end, and then the back end will unpack all these instruction, you know, especially this 9.3 plus. So it does the calculation and send back. So this is a typical, you know, a very interesting example for web programmer to learn forth or vice versa, right? And okay, now this one, okay, this is an example for this is actually a one cell table, yeah. Although it doesn't look like a table because it doesn't have border, but the HTML code is actually like this. Now it's actually generated using this line of the phoscript code. Okay, it's written in PHP. So you have this TD, TN, and so on and so on. Now TN means a tag name. TD means that the TD is actually the table data cell, right? R means row and table. So this is how we actually generate HTML from reverse Polish notation. Now, I would say that the academic circle may be interested, you know, in this, right? Where because this is what they usually call unification, right? We can actually unify reverse Polish notation using unify HTML code using reverse Polish notation. Now that is also a thing that I think might be something quite novel, yeah, but of course we need to work on a thorough literature review on that. So this is just a simple example of making a HTML table. Right, now this next one is actually, okay, I'll play a little bit of this because it's actually an animation. It is, you can see that this is a word, a fourth word or forthscript word to create a tank, all right? This is actually in JavaScript and WebGL. And there's a library called Three.js, THREE.js. So, I mean, it is quite a powerful, yeah, you can see that, yeah, it's quite a powerful library. It's been around for a long time, but of course, programming that is quite JavaScript is like quite complex. So the whole idea here is to simplify JavaScript. So this is the kind of things that it can do. Right. All right. Now let's move on to the next example. Now this next example is actually a clone of the Zoom application. It's called JitSimit, JITSIMEET, JitSimit. And in this case, I'm not sure whether the animation is running properly, but anyway, what I try to do is that I try to create a 3D avatar of myself. All right. Yeah, and so you can see that these are the forthscript word that I created. So it interface also to the 3JS library within this JitSimit. So this JitSimit actually is actually written in a React.js, which means that the same code can be actually ported to mobile phone, Android, iOS, as well as the website. So I think this may not be working, but yeah, if you want more detail on this, I can send you the link of this thing. Yeah, right. So now, okay, now this part is actually just a concept that I have actually tried try for maybe like a few weeks. I haven't really gone too far. This is also something that I think Brad mentioned just now. How to port forth onto the web programming. Now I think what Brad did was that he used ASM.js. ASM.js I think is equivalent to WebAssembly. But my idea was that to actually hack the Firefox source code directly, right? So that we can actually put in the all kinds of forth assembly code, right? Like Jones forth being one of the classic one. Might not be the best, but that's what I had at that time. Yeah, I would estimate this may take a 1 man month to complete. Yeah, with with someone interested. Yeah, and yeah. So anyway, it would be quite interesting to see that if you can execute forth directly, right, in the browser instead of going through the WebAssembly. I think yeah, Brad also mentioned about performance issues. So yeah, this is something that yeah, I try to work on, but of course I didn't try to sort of complete it. Okay, now this next one. Okay, now this screen is actually another interesting project called Sim Engine. Okay, I rename it SimForth, as in SYMFORTH. You can see the details inside the video. What Sim Engine is actually a C++ symbolic mathematics package. So I think it started as a SimPy. Someone in the Python programming community tried to create a symbolic manipulation package, meaning to say that all the equations, yeah, like like this kind of equation, this one is actually x plus y to the power of 5, yeah. And if you look at the code at the bottom here, all right. So I translate x plus y to the power of 5 into reverse Polish notation, right? Or forth, or whatever we want to call it. So yeah. So you see that you have a 2 plus 3 sorry, yeah, 2 plus 3 is 5. Then you have so it can do this quite easily. But the reason why I'm interested in this is because I thought that just now Greg was talking about teaching kids about designing hardware. So I thought that this kind of I would say college level or university level calculus, right, or algebra, can actually be simplified into fourth notation and taught to the high school students as well. Yeah, so this is one of the idea behind. I mean, after experimenting this, I found out that it is quite simple. Then obviously the next thing to try out is actually to find some high school student to try it out. So this is one of the thing. Yeah, this sim. This sim engine is quite powerful, and in fact, one of the interesting idea in this C++ is this data structure called RCP. Yeah, it's a generic kind of pointer that you can use to represent anything. So I use that to create a stack machine, right? To implement the fourth engine that I shown earlier. Okay, so there's okay, now this one is actually an old program. Okay, this is actually yeah. So you can see there's some animation here, but of course it's actually written using C++ based on a bullet and OpenScene graph library. So this is just to demonstrate that how I can use the idea of phoscript to interface to something more complicated like this. Okay, so this is the kind of data structure that I try to declare. All right. Yeah. Okay. So that is the old work actually. Something that I have worked like maybe 1 or 2 years ago. Now the next one is actually, this is example written in Kotlin. Kotlin is a cousin of Java. So this is for Android app. Yeah. So you can use this to write Android app as well. And of course, you can also do this is Python. Yeah, you know that Demitri mentioned that something that he loves to hate, but like, okay, see the whole idea here is that if we can write forthscript in Python, then we don't have to use Python. Yeah, so that's the idea here. Okay, so that's another representation. Now this is I think maybe one of the most interesting one in Bash shell itself. Okay, and Bash shell, I'm sure everyone has to deal with Bash shell, and there are so many commands in Bash shell or some utilities, for example, ffmpeg. If you deal with multimedia files, then you know that there are so many parameters you can never remember. So I started writing this forthscript in Bash shell because I don't want to remember all the parameters for ffmpeg because it's just impossible. So yeah, you can find this on my GitHub repo. Okay. Now the most recent one I do is actually what I call this reverse react notation. Now it's the same thing. It is all forthscript. The reason is that I started creating some new names because I thought that younger programmer may want to it's a marketing thing. Yeah, if you call something sexy, then maybe they'll pick it up. Now this is the kind of forthscript code that you do, and in fact nowadays React code is very advanced. I mean, the tools for React, you can write. They actually hosted the whole of the React compiler and everything on the website. So, for example, this code produced the invoice app, like shown on the right hand side. In the middle is a code. So it's a complete IDE inside this thing. But of course, you can see that the syntax is getting too complex, right? So I thought that, if I can actually simplify it to reverse Boolean notation or forthscript, or, forth style, that would be nice, isn't it? Now, so this is exactly what I try to do. I turn this thing into this. Now, although this thing doesn't look like much, but it's actually a one big step, because you can actually use a colon definition to combine a very long constructs of this React syntax into it. Now, I want to say that React is probably one of the most popular framework used by mobile phone programmers nowadays. So, you know, in order to appeal to the young people, for them to pick up forth, yeah. So that's why I started doing this. Okay, so you can see that these are some of the examples, the code that I wrote, right? So it's like, it is a very simple idea, you know, you just write the React code inside, so that the programmer, that means yourself, you don't have to remember it, so you just remember the forth syntax. Now, in fact, there is no forth syntax, so you don't have to remember anything. So that's the whole idea. Yeah, so this is how it started. Yeah. Now this FGL is actually taken from the earlier example, some 2-year-old code that I have written. Yeah. So as you can see, it's quite stable. You can actually put it. Now the latest one I'm working on is this idea, so that a programmer does not have to write program anymore, right? Because in fact, I'm sure you already realize, right? A lot of the work that we do is actually copy and paste, right? So we just find code and then change it. So if we can have a script that can, you know, replace code or change code, so it's a different way of or different level of meta programming. So I call it phoscript, for find regular expression and edit. Now, another reason I call it phoscript is because you see, Python was named after Monty Python. So phoscript, I thought, you know, to remember Freddie Mercury from Queen. Now, so the example given here is a very classic library called data tables. I'm sure anyone who does web programming knows this. Now, so this is what the code of the data table look like. Okay, it looks exactly the same as the ordinary HTML, except that it has a JavaScript code. So what I did was that, okay, I embed the phoscript code or forthscript or whatever you want to call it, okay, inside the command, okay, with this double colon FDS and so on. So you see, any line that has a double colon FDS double colon is actually a phoscript command, right? So for example, this line here, okay, you can see that this is a data token, okay. So this array word, create an array of that and then join them together as a string. Then this table content, okay, whatever, okay, create this line, okay. So yeah, so this is the idea to, you know, to I mean, to write a program without writing a program. Yeah. So this is the output. Yeah, you can see this is a stack. So this is the output, right? Okay. So now the last one I want to show. Okay. Now this is just the implementation of the of this phoscript. Now I discovered something quite interesting in JavaScript, right? That is, I would call it.
Sorry to interrupt. Could you get it to converge? Maybe take a question or two and wrap it up.
All right, sure. Now this is called I would call it array machine, right? You split the thing into array and map it into a function, and of course we can go into more detail about array machine compared to stack machine. But this is quite interesting from JavaScript. And okay, I want to just show this. Now, this the idea of phoscript, right? We can actually implement into any programming language, which means we can turn any code into hash. Okay, so if you actually look at this, now I have a demo, but I won't go through demo. I just explain the idea here. If you just take the phoscript code, okay, or any kind of forth code that represent a program and turn into a hash, then we can actually make this hash something that is like legally traceable, so that, you know, if it's sort of one of the biggest problem in programming today, because like we share code, like free software code, like without being able to charge those who use the code. So this is the whole idea. So we can actually claim that this code belongs to us because of this hash. So that's all I want to present for today. And I'm sure, as you can see, there are many things that you know, we can go into detail. All right, thank you very much for listening. Thanks for your time, and yeah, thank you very much.
Any questions? Yeah, you want to mute him. Input, everything muted.
Can you?
I'll
No.
tell you in a sec if I can hear you.
The audio test didn't look like it was working. No.
All right. Yeah, I can hear you. I can hear me.
How about now?
I can hear you now.
Okay. Well, you're right in front of me. Of course you can hear me. Hold on.
No, I can hear you through my
All right.
earpiece.
Okay.
And it says okay.
That's
It's
me.
slightly delayed.
I'll just leave the camera on just to say hi. I'm going to turn it off and I'll share my screen. Hello, everyone. I'm Leon from Forth Inc. And I'm going to talk to projects I've been working on today. The first one was porting SwiftForth to run on 64-bit. And the second is a tiny little Raspberry Pi chip. This is as loud as I can talk. You can't hear me?
Barely now.
Oh, no.
Yes, stand up and get a presentation.
I can't reach the keyboard. Okay, hold on.
Talk like a Green Court DI.
All right.
Yes, there you go. All right, folks, listen up.
Stand by. How do I share the screen?
We can
Not
hear
always-
you fine out here, I think. I
Can
can.
you? Yeah, I'm gonna deafen you in a minute. Sorry. Turn off my camera. Okay.